Fire escape evaluation, 12 North 3rd. We have a 5-story fire escape here. And the one thing that we're going to be looking for is, the law is very simple. In its lifetime must be structurally sound, must be kept painted. So the first rule of thumb is, have they been maintaining it? Is there more paint than rust or more rust than paint? And when you look up, you can see that majority of the fire escape is still in the black. So, but have they been maintaining it is going to be the second one. Because you can go looking at other fire escapes that have a lot more rust and paint. But this one, they try to keep throwing paint on it. But have they been maintaining it structurally? So now, the next thing you want to look at is the structural connections. This building, if this fire escape is 50 to 75 years old, you're going to look at the original hardware. Has there been any evidence of the hardware being switched out in its 50 to 75 year life? Meaning they've been painting it many times in 50 to 75 years, but has this owner or the previous owner spent any money on changing of bolts? And you got to look for hex head bolts. Otherwise, if you see nothing but square head bolts, see the original square heads on the supports, square heads there, you start looking for what's easier. Is it easier to find new bolts or easier to find all the old bolts? And on this fire escape, I'm looking for evidence of any maintenance in 75 years. I can't see any on the cantilever. I can't see any on the treads going up. I see major structural issues in the joiner plate there. I see major issues on the hangers because it's all still original 50 to 75 year old bolts, indicating that this fire escape has no evidence of any maintenance from down here. We're going to get on it, but it doesn't look good already. That this fire escape is probably going to need a 50 to 75% refurbishment of minimally all the superstructure. So if I'm an engineer and I'm going to sign off on this, I want every one of these treads rebolted because they're 50 to 75 years. And if you're ever going to get hurt, you're going to get hurt on a tread. So let's get those out of the way today. And this is not a recommendation, this is a must, because I got 50 to 75 year old bolts on my treads. Now, superstructure, which is the main supports and all, those are 50 to 75 year old bolts. Usually in a lifetime, they're already been swapped out. If they haven't been, I'm going to do one of two things. On every one of these supports, I'm going to refurbish a bolt that I classified as good to excellent, and it's 50 to 75 years old. But because I can't get inside to the meat of it, I'm just going to back it up with another bolt. Keep the original, back it up. Or if it looks like it's already suspect, I'm going to change it out. So that's what I'm going to do on the superstructure. On all the minor structural, railing connections, I don't need to change those out. I just need to verify that every connection is in good to excellent condition with a 50 to 75 year old bolt, because none of those will ever hurt or kill me. Okay. But all the joint, all the railing corners, sometimes some of the post corners, those are considered part of the critical structural. Okay. So on this fire escape, as it is from here, minimally right now, we're looking at all the treads being rebolted and all the supports holding up the platforms, minimally the superstructure being reinforced or rebolted. That's it so far. From here now, you see those tiers coming down on the cement? There's an unknown. 98% of this fire escape I can see from the outside, and we're going to walk it and take photographs. But there's an unknown into the building, and that unknown is sometimes identified when we got rusty tiers coming from the wall. So if I got any spalling of the cement, I got to repack that and tighten it back into the building. But this 50 to 75 year old building now needs to be confirmed that it's properly attached into the building. Sometimes when the building is gutted and something's happening, I see it. You can see it on the inside. Sometimes you can't. I have two choices. I can drill it from the outside and verify samples that there's no damage in the wall, or forget about it. It's cheaper. It's $200 for me to verify a connection. It's $20 for me to drill a hole, put an epoxy bolt in there, mechanically fasten it back, keep the original, tie in the second one, and we're golden on this fire escape. So that's the other thing I'm going to be looking for. Okay?